Hi everyone, this is Maxime Dupuis, and today we'll try to solve the Project Euler number 26. So, the last video we solved the number 25 and we got an achievement to solve the 25 first puzzles, so that's pretty encouraging. Now we'll try to work on the second achievement to get the first 50 puzzles. So let me show you my screen. This is PyCharm. So as usual, I did not read the problem beforehand, so we'll figure it out together. Reciprocal cycles. A unit fraction contains 1 in the numerator, like these examples. The decimal representation of the unit fractions with denominators 2 to 10 are given here. Okay, so the unit fraction of 3, for example, is this. And the decimal representation is like this. I don't know why they have parentheses, not everywhere. Okay, where 1.6 means infinite sixes, and has a 1-digit recurring cycle. Can be seen that 1 over 7 has 6-digit recurring cycle, because all of them repeat indefinitely. Find the value of d smaller than 1000, for which 1 over d contains the longest recurring cycle in its decimal fraction part. Interesting. So d is under 1000, so 1 over 1000 is the maximum number we have to find, which contains the longest recurring cycle in its decimal fraction part. So I guess the division part is easy, we don't need a function to do that, well, test to do that. But if we want to go TDD all the way, the first test would be to make sure it gives us this kind of format. So the unit fraction with denominator 2 should give us a string containing this number, 0.5. Well, actually, we only really need the decimals. So the part after the dot, because they're all fractions up to 1000 and infinite, it will always be 0 point something. So let's get a function that gives us just the decimals in a string like this, and if it repeats, it should give us the repeating pattern in parentheses. PyCharm. We want to get the decimals of what's it called? Of the unit fractions with denominators. Of unit fraction with denominator. And it might not be super obvious which is the name, but that's why we write unit test, so the user can, if they're not sure, look at the test and see examples of what it should give them. So, for example, this is for the denominator 2. Let's have some examples here. So first, we'll do the simple cases where there's no repeating numbers and no parentheses. So it would go, so with 4 it's 25. 4 is 25. We'll write it in the test without repeating pattern. So 5 is 0.2. 5 gives us 0.2. 6, no, that's repeating. 8 gives us 1.25. And 10 gives us 0.1. Oops, I skipped this one. Let's remove it. Alright, so baby steps, denominator, not terminator. So we'll move this function the source folder as usual, work on it. So it's called a quotient in French. What's the result of division in English? A dividend is divided by a dividend to find a quotient. Okay, it's the same word. The quotient is 1 divided by the denominator, and we want to find just the part after this. So if we do times 10, it will move not exactly. We'll do a string manipulation instead. So if we convert it to a string, so the quotient string is this, and so at this point we'll have something like 5, for example, for the first example. So we want to get rid of, in these cases it's always unit fraction. We know that it's always 0 point something, so we can just get rid of the first character and we'll get rid of the point, the dot. So just the decimals string. The decimal string will be this, but we don't start from 0 to the end, right? We start from the first character, the character at the index 1, which is the second character. So we skip that dot, and we can return it like we'll just return it like this. No need for a variable here. And we'll space. Run the test, and let's see. So we expected 5 and we got 0.5. So it probably, my guess would be that the string as starts with 0, then 1, and then the point. So we'll just skip the first two characters. They will all start with 0 dot something, and this works. Now if we do this, we will do a commit. So add everything, just status first, add everything, commit, work in progress, solve when no repeating characters. this is a temporary commit. We'll just a reminder for ourselves, and so we can come back to it later on if we make a mistake. So our test is the same name. Get decimals like this. But with repeating pattern. And the examples they give us is 3 gives us parenthesis 3. Six gives us 1 parenthesis 6. Oops. 7, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 plus 4 gives us 9 cases. So of course the test fails right now, because we have 3, 3, 3 infinite 3s. So now what we need to do is fine. Yeah, because just with this information we don't know for sure that it repeats forever, right? Maybe it's 1,000 trees and then a 4, and so it doesn't repeat like this forever. So feels like we kind of need to do the division by hand. And you know, when you do a division by hand, you always divide by a part of the number and then have a remainder. And once you hit the same remainder, you know that it will, like, say we have the result gives us 2 and 4 and 5, whatever, 7, 8. And when we have the 5, the remainder was I don't know, 24, when decimal is 5. If at this point the remainder is also 24, we know that it will repeat from the 5 forever, like this. So they write it using parentheses like this. So it was 24 before, the decimal is 5, and 24 after the decimal 8. So after the 8 we have the same remainder, we know it repeats forever, and we'll have this pattern. Let's just comment it out for now. Keep it in mind. So yeah, we kind of have to like code the algorithm that goes into dividing by hand. First, there might be built-in functions in Python to do it for us. Python quotient repeating. That's basically what we're trying to do. Let's not read it. What's the purpose of that? Is it something? Integer division. Okay, so that will be useful, I think. Not right now. So what do we do when we divide the number? Let's write it in the comments here. So for example, if we do one third, example 1/3, we do 1 is, we say, okay, it's 1 is smaller than 3, which is the divisor. 1 is smaller than the divisor. I think the term is dividend. Oops. The dividend is the number being divided. All right. So we have dividend is 1, divisor is 3. Now we realize that the dividend is smaller than the divisor, so we multiply dividend by 10. So now the dividend is 10, and now we divide it, but with an integer division. So integer division, which is dividend double division. So it's an integer division by the divisor, and this gives us a remainder. The remainder is 3 at this point. No, sorry, the remainder is 1. So that's the, I don't know what to call it, the decimal, the new decimal, yes, new decimal. So when we hit that point, we know it will always start like this, right? Because it's always 1 divided by something. So in our case, it will be easier than just regular divisions. So the new decimal is 3. So the output so far is 3. And the remainder is 1. Now what we do is dividend equals the remainder, which is 1, and repeat at this point. The remainder will always be smaller than 3 because we did an integer division. So we can go back to this point. Repeat all this. Oops. Repeat this. And when we hit, like, it will repeat forever until we hit a remainder that we already saw, like in this example, or a fake example, where before the 5, the remainder, so at this point the remainder was 24, for example, and it gives us this. So we have to remember all the remainders. Make a note of this. Remember all the remainders and the corresponding index. I can type corresponding index. Okay, so in this case we have a remainder of 1. So we have some kind of dictionary like this, where a remainder of 1 gives us the index in the output, right? The index of the decimal. So it's the 0th decimal. So we have to have a variable here for the index. It will be 1, not at 0 first. And so as we said, we can kind of skip this thing. The dividend is smaller than divisor because it will always be. So let's just get rid of it. Index is 0. And at the end of the loop, increment the index. Make sure we keep track of where we were for each remainder. So then on the next loop, we multiply dividend by 10. So it was 1. We're back to 10 in this example. And well, actually we can remember the dividend. Or if we would just start and like pretend this variable is the remainder, so there's no need for a dividend. No, let's keep those variables separate, even if they correspond really closely. So every time in the code that we see the remainder, we know that's the real remainder and not like a temporary variable. That's otherwise it's too hackish. But we can remember the dividends instead. Or yeah, I like the remainder more, because when you do it by hand, that's what you look at. Like, okay, this is the same remainder as before, so now it's infinite. So let's just make a variable that copies the dividend. So it's 1 dividend. And each time the remainder is updated, we'll have to update the list. Update. How shall we call this? Like a remainder memo. So now the remainder memo contains 1 at position 0, so we'll put the index before everything. So on the first pass, we update the remainder before even entering the repeat loop. So then we multiply the dividend by 10, divide the, and at the end we have a remainder of 1. We go back to the top, repeat, and at this point, the stop condition is that the remainder is already in the memo. If the remainder is already in the memo, we know that what was at position 0, everything from position 0, where the memo is, up to where we are now. So we'll like break from loop at this point, and after we break from the loop, we will update the output so that everything from the found remainder, yeah, that's the remainder memo. I can't type memo. Remainder memo. So now everything from the index in the memo up to current index. In our example, the current indexes is now it's 1. So the output from 0 to 1. This is the part that will repeat forever. So we'll replace it by itself in parentheses. Replace by itself in parentheses. So now what we end up with is an output which is, instead of 3, it will be 3 in parentheses, which is what we expect in our test. So we can run it for 6 in our head just to make sure it works. Parentheses. How do you type this? You can't type parentheses. 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 We got it. Okay. So if we do the same example and we can get rid of this thing now. So we have a divisor which is 6. Divisor here would be 6. Index is 0, dividend is 1, remainder is 1. Update the remainder memo with a 1. Yeah, so at position 0 it will always start like this. And now we repeat. Is the remainder already in the memo? Oh damn, it is. So instead we'll update the remainder in the loop after the stop condition. Okay. So at this point, is the remainder already in the memo? No, it was empty. And now we update it, so now it looks like this, 1 and 0. Multiply the dividend by 10, so it would give us 60. And yeah, yes, no, 10 divided by 6. So it will give us 1, the new decimal, because it's an integer division. And the remainder will be 4, because 10 minus, so right there, the dividend divided by modulo the divisor, or rather divisor modulo dividend. Did I do something wrong? Dividend divided by divisor. No, it's divided by divisor. So 10 divided by 6. The remainder would be 4 at this point. And then the remainder is, well, they're both the same. The dividend, the new dividend is the remainder, so 4 I mean, and we increment the index. Okay, so the remainder is not already in the memo because the new remainder is 4. 4 is not in there, there's just 1. So we update it. So 4 gives us index 1. But I won't mess with the example because it works for 1/3. Now dividend is we add 4, so now 4 divided times 10 gives us 40. 40 integer division of 6 gives us 6 by 6 gives us 36. So that yeah, 40 divided by 6 gives us an integer division of 6. Yeah, so that's a new decimal, that's good. Not 36. And the remainder will be 40 minus 36, which is 4, and now we hit the same remainder that we add, the 4, so in the next loop it will realize that it's going infinite. So we'll take this pseudocode and bring it to here. Okay, so I think get decimals of unit fraction. So we kind of have to get rid of this because this will never work. For infinite, like we're going to need parentheses and everything. So just get rid of it. It's in source control if you need to have a look at it. So now we have index is 0, dividend is 1, remainder is dividend. Right. Remainder is the dividend, so it's 1. We don't have to write the 1. The divisor is the divisor is actually the denominator. So I made a mistake here. Replace divisor by denominator. Replace. Just make sure we use the same word everywhere. So we already have it, the denominator, so we don't need that line. And repeat forever, so we'll have while true. The stop condition is if the remainder is in the remainder memo break, so it will break out of the while true. Remainder memo, we have to initialize it. We didn't do it here, but we have to. So initialize memo. So what we're gonna do is remainder memo is an empty dictionary or map. In other languages they call it a map. And after we break out, I'll figure out later. So the stump condition is already in the memo, break from the loop. We got it. Update the remainder. So remainder memo point add. Update. We'll have a look at what it returns or something. If it's no, I guess it's the remainder will never be in the memo. Otherwise, we would have broken out. So we don't need to check it. So remainder memo. I don't know why. Predict Python add element. How can I append to a dictionary in Python? Is there an append button? Adding a new key pair. What is this? Update and some kind of sub dictionary. No, that's not it. If key is a string, you can directly add without curly braces. That's not our case, because the key is not in our example. The key is not a string. It's I don't know what it is, a constant or something. Update existing. All right, let's just do the update with this curly braces thing. So update. Curly brace remainder and the index. So we're here, update remainder memo, multiply dividend. So let's multiply it by 10. So that's just a note. It's nothing. Integer division, so the new decimal is the integer division of the dividend, integer divided by the denominator, and the remainder is the dividend modulo denominator. So we're here. The dividend is the new remainder. We increment the index. Index is equal to 1. Everything from the index in the memo up to current index replaced by itself in parentheses. So where we have the new decimal, we need to add it to the output. So we need a new variable, which is the output, or you can call it the decimals, since it returns the decimals of blah blah blah. So it's an empty string now. The decimals will append. Can't append to the string. It's like this. Append to the string the new decimal. I think it will convert it automatically to a string. Otherwise, we'll add a cast. But I think we're good for now. Yeah, I think what I would like better is to have an array to make more sense conceptually. To have an array of all the decimals, and at the very end we will convert them to parentheses and like the string format. So we'll actually append the new integer here, the new decimal. So when we leave the loop, we have some kind of array here with, for example, when we divide by 6, it's 1 and 6 decimals. And now we said everything from the index in the memo up to the current index. So what we can do is convert it to a string here. So decimals string is, we will join the decimals with nothing in between. So now we get something like a string with 1 and 6, and then we will replace in the string decimal strings. Replace, what was it? I want to see the back. Self, okay, it's self, we don't need that. Old and new. So actually it's not that we want to replace a specific substring. We want to replace from some index. Okay, first let's make a variable for the repeating part, which starts at the index, from the index in the memo up to the current index. So it starts at the index in the memo. So the index in the memo. The index of the current reminder. Right until the end, right? So we don't need to have a ending. So that's the start. And the repeating part is decimal strings from the start up to the end. We don't care what the end, where the end is. And that's the repeating part. And we can replace it, I guess, replace the repeating part by like this, parenthesis plus repeating part plus end of parenthesis, and hopefully return it. That's a lot of code, so I'm not sure it will pass on the first try, but we'll debug through it and see what's up, and then we'll clean all the comments that are no longer necessary. So what does it do? That's some weird error. So it doesn't compile because there's a type error at this point, because the decimals are not an array or something. Let's run the test and debug. Let's see. Because we told it to be an array. Okay, so at this point, what we're testing with is denominator 2. So it should give us the string 5 at the end. So where are we? We have the decimals 5 and 0. If it's 0, we don't want to add it to the output. If the remainder is 0, we should get out of the function, or remainder is 0. Shouldn't get out. Okay, so we're in the same place. The decimals is 5, which is good. The denominator is 2, the dividend is 0, but we don't care about it anymore. The index is 1. The new decimal is 5, and remainder is 0. It's all good. But the decimals, it's a list. Why can't you join? Can't you join a list of 1, 2, and 3, for example? Expected string and stance, what we found. Okay, I thought we could join anything and we just print it. So join, I guess what we could do is, let's just do a quick Google, just make sure there's no super easy way, but I would do a, just convert every int to a string and then join them. So Python, how to join ints. Join a list of items with different types. Join a list of integers. There's no super easy way, so we'll just, where are we? Here. Join. Instead of decimals, we'll have the string of a decimal for each decimal in decimals. I think that's what we want. So for every decimal, like 1 and 6, convert it to a string, and then join all the strings together. And this test still failed, but for a different reason. Expected 3, actual 3. Okay. So add this. Fills here, and here because there's a key error. So I guess if there is a remainder of 0, we can skip the reformatting part because we already have the good decimals. So all this thing would be if the remainder is 0, return the decimal string. We'll have an early return, and then a more complex part. In case the remainder was not 0, then it means that if you broke out of it, it's because it was in a memo, and then there's a repeating part. So yeah, that works. The first test passes. So now the failing test is the repeating pattern. And it gives us, we expected parenthesis 3, and we got just 3. So we'll break again at this point maybe. Let's see, so we expect the decimals to be just 3. The repeating part starts at the index in the memo, which would be 0. So it starts at 0, we're good. And what does this give us? Repeating part is the 3. Okay, I don't see a problem with that. The repeating part is 3. And we want to replace it. So decimal string was not replaced. Maybe it doesn't modify the string replace, but it returns a modified string. So we'll return it like this. Run the test again. And it passes. Alright. This is the first time I code the end division like this. So now we can get rid of it. Since it's so close to the code, we don't need that comment. It would just repeat itself and like maybe rot because we'll change it later or something. So the test is a good documentation, and if someone wants to understand it more in depth, they can break into it and see. This way it will not be a rotting comment. It's better to have no comment than bad comments, in my opinion. So now all the tests pass. What were we trying to do with this? Find the value of D for which D contains the longest recurring cycle in its decimal fraction part. Alright, so D is the denominator, smaller than 1000. So I think we can go straight to the main. So let's find each of those values. And then find the value of D, which D contains the longest recurring cycle. Now, let's do a test. Because 2 Project Eulers ago, I skipped the test before doing the main. I skipped into the main, and it went bad. It lost a lot of time. So let's do a test, and we'll get the denominator, which contains the longest recurring cycle. Get the denominator containing longest containing most decimals. Assert this would be the function name equal there. So get the denominator containing the most value. So if we have just, so we'll give it a maximum denominator. So for example, if the maximum denominator, oops, that's the max denominator. If the maximum denominator is 2, we'll go up to this, and it will return that 2 has the most decimals, which is just 1 decimal. Oh, the longest recurring cycle, so it will return none. What's up? Comparison with none perform with equality operator. So it means that we need to have that is like this, because the longest recurring cycle. I guess the second denominator has the longest, but the length is 0. So we can see it like this, and do it like that. So the denominator containing the most decimals. The most decimal is 0. Another example is 3. With 3, the one containing the most repeating decimal is 3, because it has 1 repeating decimal. Then up to 4, it's still 3. 4 is still 3. And for example, with this special case where it has some non-repeating and some repeating, it's important to have this edge case. So 6, because the most decimal will just return the first one that has the most, because this one has 1 repeating and 1 repeating. It's still 3. So this will make sure that it does not count, like, I don't know, just the length of the string, and then we'll have a length of 4 and it's bigger than 3. So just to prevent ourselves from doing some hacks. 7, up to 7, the most is 7. Up to 8, the most is still 7. And I think that's good enough for now. So let's move this to the source. This is the function. Okay, so all the decimals strings will be that for each like this. Each element will be this, using a denominator for each denominator in range from we'll start at 2 and finish at the max denominator plus 1, because if we want to, like, say, go up to 3, we want to actually try to divide by 3, and range will give us a list of just 2 to inclusively 2 or exclusively 3. So now we're inclusively up to 3. So that's the decimal strings, and then we want to get just the part that's inside the parentheses. So we could use a regex expression. Let's just see how regex is the syntax in Python. Python 3, maybe it has changed. Regular expression. Okay, let's see. Regular expression example. Okay, regular expression. re.match pattern inside this string. So first we want to import this. The string is the decimal string, and we want to get just the, I guess match will return the string. To match regular expression pattern to string with optional flag. Here's the syntax. What do you return? A match object on success, none on failure. Okay, so first we could go for could, what we want is like just the repeating part of each of those strings. So repeating decimals, and it's an array the same length, and for each we will do this some kind of function. So we'll declare a function here that extracts the repeating decimals, extract repeating decimal and decimal strings. So what we have to do is this. If it does not contain a parenthesis, for example, that in decimal strings, the repeating decimal is empty. What up? Expected one blank line. Sure, pep 8 is not used. All right. So let's figure the logic after, but we'll need to extract the repeating decimal for the decimals for each decimal strings. Oops, for decimals and decimal strings. So now we'll have, our goal is to have just the repeating decimals, and then we want to have the length, I guess, length of repeating decimals. So we have length of repeating decimal for each repeating decimal and repeating decimals. So now we have an array of just the length, just for example 0, 1, 0, 0, 1, 6, 0, 1, 0. Just the length. And now we want to have the index of the maximum. Let's find a smart Python way to do this. Index of max in list. The index of the maximum element. Okay. So index of the maximum element in itself. Okay. And now we need to figure yeah, the regex. Oops, I closed it. Match. Search versus match. Python 3. Let's see what all the functions are. Blah blah blah. The symbols. What are your functions? Compile. Prog equal compile pattern, and then okay, so you can compile a regex and then match it several times. I guess it's equivalent to match a pattern directly. So it's more efficient if it's reused a lot. We don't care that much about reuse now. Search through string, looking for the first location where the regular expression pattern produces a match. returns a corresponding match object. If 0 or more characters, blah blah blah, return a corresponding match object. Return none if the string does not match the pattern. Okay, so that's just if you want to match since the start. But what we want is to search anywhere in the string. Let's see, we'll debug through it and see what it gives us. So we want to search anywhere where will be a string like this. As well, parentheses. Then like some numbers and another parenthesis, and what we want is just this part. So all the colors are weird, it's probably that is the wrong syntax. What we're gonna do is debug and try it ourselves. So the first test doesn't work because expected 2 and actual 0. Get the denominator containing the most decimals. Alright, because we calculate a bunch of decimal strings. But the first one in this array, its index is 0 and the denominator is 2. So we have to add the 2 to this, the return index. Because we start at 2. We don't support denominators like 1 or 0 or negative. And the line is too long, so we'll split it like this. Maybe another line like this for good measures. Okay, so this one passes. And this one does not because it crashes for some reason, so we'll debug and see what's up. So what we got here is the decimals string, which is parenthesis 3 parenthesis, and we want what this gives us. It doesn't seem to match anything. But if we just match anything, what do you give us? Give us the regex is this. I expect it to return like parenthesis 3 parenthesis because we match anything. If we just match one any character. Otherwise, gives us a match object, and match object group and expand. Return the string obtained by doing backslash blah blah blah. Okay, we want the first group. So that's a group. It's in the parentheses. So the return value dot group 0. Group 0 gives us the parentheses. If we say I want the 3 characters, just this one, and if I want something like that, what is inside parentheses like this. No? How do you escape the parentheses if not like? Oh, of course. I want to escape. Maybe we need escape the escape character because we're working with Python strings. No. Let's ask the internet. Python regex match inside parentheses. Return text between parentheses, and it's I guess you're right. If your problem is really just this simple, you don't need regex. Just find the 2 parentheses. This will probably give us the index of the first parenthesis. So we want to go +1 after this one, and then find the last one. Yeah, you're right, T. Corwin. So that's simpler than using regex. But since I'm curious, I still want to see. Okay, so it's R. You have to prefix the string with R, like this. Messed up. So R, I guess it means it's a regex expression. Escape a parenthesis and capture whatever is inside. Then escape the closing parenthesis. So escape parenthesis, group everything that's inside. Escape the other parenthesis. And the string is decimal string. Decimal strings contains the thing. Group 1? Why is it not the first group? So group 1 is, I guess, always the whole string, maybe? If we go, I want to find number 3. So let's capture the 3, for example. Get it? But group 0 is still 3. But why would it match parenthesis 3? they say about the groups. Without arguments, group 1 defaults to 0. Group 1. If there is a single argument, the result is a single string. If there are multiple arguments, no, we don't have multiple arguments. The entire match. Okay, because regardless of the groups, I guess, they found this pattern. So parenthesis, something, parenthesis. So this is the whole match. And then if you want to see just the groups, it will be like this. That's interesting. But we'll still go with Kerwin. What's your name? T. Kerwin answer. Because it's simpler, we don't need to use the regex package at all. So the string is this. And find the parenthesis. S decimal string, find the first parenthesis plus 1 up to the last parenthesis, and yeah, let's just overwrite it or return this, and if there is no parenthesis, return an empty string, cover or behind. So yeah, this works. Shadow names, decimal strings. So let's just call it decimals, whatever. Decimals. Okay. So now we can get the denominator containing the most decimals, and the question was get the one containing the most decimal smaller than 1,000. So we're going to do up to 999. Next, print this denominator containing most decimal up to 999, and run it. It's not defined because the main has to be at the end. Rather, this part has to be at the end, but I like to keep them together so we don't look too far away. So let's run it, and we get a number, and the 983rd denominator gives us a big repeating cycle. We don't even care about what's the length. Just that it passes the test. So we solved the problem using TDD. So I really recommend the TDD method. It's useful, as you can see, to make sense of a complicated problem. So you give yourself some examples like this. Make sure to put all your assumptions into code. So you're safe. You know that you won't break any assumptions in the future because the test will tell you. And when a test breaks, it tells you pretty much exactly where the bug is, the line of the code that's crashing or something. So it's really easy to debug something that doesn't work. For example, in a big application, if your boss tells you to fix a bug, you can create a unit test that repeats the bug, and so now the unit test will fail because it will fail because there's a bug in the code, and it will tell you pretty much where the problem is, where the function causing it. Or you can, if the stack trace is not obvious enough, you can debug with this button, debug through your unit test instead of the real application, debug from the unit test, and there will be a lot that, like, the program will have a lot less states and variables everywhere that can change the results. So you have a really contained experiment where you can find the bug and then fix it, and hopefully, if you're doing it right, all your tests will pass, and then you can commit, and your job is done. So that will be it for today. I hope to see you soon for the next videos. So see you later.